Hello everyone, welcome to the Nomenclature Workshop. In this video you are going to learn to um, name compounds. There are ionic compounds and covalent compounds. The way you can tell an ionic compound from a covalent compound is whether or not you have a metal and a nonmetal. So if you have a metal and a nonmetal, you're going to have what is called an ionic compound. So I forgot to mention in this video, we're just going to go over the nomenclature workshop. As I go through, you can fill out the answers as I'm going through to the examples. When we get to the point of doing more practice, you should pause the video, see if you can name these correctly or give the correct formula, and then restart the video to see how well you did and see if you made a mistake or not, and if so, where did you make your mistake. Okay, so I will go through some examples and explain what's going on, and then you will pause the video and do more practice, and then restart the video and then continue, and in like manner in other parts of this um, nomenclature activity. Okay. So the difference between an ionic and a covalent is the existence of the metal. So in ionic compounds, you have a metal and a nonmetal. Oops. You have a metal and a nonmetal. For covalent or molecular compounds, you're going to have two nonmetals. Each has a charge. Okay, so we're gonna start with the ionic compounds. So type 1 ionic compounds, these are gonna be your binary compounds. And what that means is that you have a metal cation and a nonmetal anion. And they're just one kind of atom each. So you'll have one kind of atom that is your cation, and you'll have another kind of atom that has your anion, or element, I should say. So the metals is going to come from groups 1 and 2, which is your S block in the periodic table, or they're going to be silver, zinc, cadmium, and aluminum. And the reason for this is because the charges on these do not change. They're always what they are here. So silver is always a +1, zinc is a 2+ charge, cadmium is a 2+, and aluminum is a 3+. A little later on, we'll talk about elements that have variable charges. They don't always have the same charge, so you have to name them differently. Okay, so in this case, we're dealing with compounds that don't change their charge. So the way you name these is, and with all naming, as long as you know the names of the ions, sticking, if you know the names of the ions, then all you do to name the compound is stick those names together. So if I know the name of the cation and I know the name of the anion, then I just put those together and I have the name of the compound. So that is pretty much in a nutshell how to name. You just need to know the names of the ions. Okay. So here, if you know the metal cation, that's just going to be the name of the element, whatever the element's name is. If you know the non-metal anion, that's going to be the name, but you have to drop the ending and add IDE. So you keep the root and add IDE. So we'll go over a couple of examples. So in this example, we have Na2S. So we look at Na first. So you're going to need your periodic table. So you find your periodic table and you find Na. Okay? So my periodic table doesn't have the names on them, but hopefully yours does. So that's going to be sodium. So that should read sodium on your periodic table. Let me get see if I can get a periodic table that has the names really quickly. I didn't notice that until now. Here's a periodic table. It's hard to see, but if we zoom in a little bit. So you can see Na. So Na is sodium. So you're going to take so then you're going to, since the metal is first, you're going to write its name first. So sodium. Okay, so what about S? So you look on your periodic table. So we find S. Where's S? S is here. So what is the name of that element? So S is sulfur. So you're going to write sulfur, but what you need to do is you need to drop the ending. So sulfur, you would drop the UR in this case, and then you would add IDE. So the name of this compound is sodium sulfide. Okay, let's try this one, MgCl2. So again, you have your metal in group in the S block, magnesium, and then you have your non-metal chlorine. So we're going to name the metal first since it's first in the formula. So we look on our periodic table and we find Mg there, and so the name is magnesium. So we write the name magnesium. We don't have to change anything. So magnesium. Okay, so that's the first part. That's the name of the first ion, and now the name of the second ion. So we look that up on our periodic table. We find it's going to be a non-metal, so it's going to be on this side. And there it is, Cl, which is chlorine. So we're going to write the name of that one. So it's chlorine. However, we need to drop the ending. Now this time, the ending is going to be INE. So we're going to drop INE and add IDE. So the name of this compound is magnesium chloride. Okay, so that's how you go from the formula to the name. Well, what about going from the name to the formula? Okay, so you need to use your periodic table, and you need to use the reference guide that you have. So here's kind of like your reference guide. Let me zoom out a bit. Okay. So here, this is something that you have. You have the names, common names of your anions that are in these groups. Notice all their endings are dropped, and they add IDE. Also, you have some the names and formulas for the polyatomic ions, which we'll get to. So you can use this to help you. Okay. So So when you use your periodic table, one of the things you should know on the periodic table is that you can figure out the groups, the charges from the groups. So if we're looking at the A groups, we're only looking at the representative elements or the main group elements. Those would be the A groups. The rule for remembering the charges of the groups is if you are in groups 1A, 2A, or 3A, then the charge is the same as the group number. So the group 1A charge is going to be 1 plus 1. That means everyone in this group is going to have a plus 1 charge. If you're in group 2A, you're going to have a 2 plus charge. So everyone in this group will have a 2 plus. And then over here for 3A, you're going to have a 3 plus charge. So the group number is the same as the charge on it. So these guys are going to have a plus 3 charge. We're going to skip the middle one. This is group 4. Group 4 is we're going to skip because that could go back and forth. It could be plus or minus. So we don't usually look at that. So groups 5, 6, 7, 8, the rule there is the group number minus 8. So if you know the group number, you could subtract 8. That's going to give you the charge in that group. So 5A is going to be 5 minus 8. That's going to give you a negative 3 charge. Group number minus 8. So group 6 minus 8 is going to give you a 2 minus charge. 7, group 7A, 7 minus 8 gives you a negative 1 or 1 minus charge. And 8 minus 8 gives you 0. So these are the noble gases. They do not have charges on them. They are neutral atoms. So this is the way you can remember the charges. So here I have aluminum. So one of the things you're going to do is you're going to figure out what the ions are in the name, right? And you got to keep in mind that the overall formula has to be neutral. So the charges and the ions need to balance out to get 0 charge overall. So the way you can do this is you can, once you figure out what the charges are, what the ions are, then you can crisscross the charges and write them as subscripts. So let me show you how it's done. So aluminum, you're going to look up aluminum on your periodic table. So that's going to be Al. Al is in group 3A. So that's going to have a 3 plus charge. So you write Al 3 plus. Then you got oxide. Oxide, that's oxygen with the IDE ending. So you're going to look up oxygen O. So here's O. Oxygen is group 6A. 6 minus 8 is 2 minus. So that's got a 2 minus charge. So we're going to write down the symbol O, and that's going to have a 2 minus. Now that you have the ions written out with their charges, how do you get the formula? Well, you're going to crisscross the numbers on the charge. Don't crisscross the charge, just take the number. So I'm going to take this 2 and I'm going to move it down here as a subscript for the aluminum, and I'm going to take this 3 and I'm going to move it down here as a subscript for the oxygen. So then what I end up getting is O3. O3. Al2O3. So that's the formula for aluminum oxide. So let's do this again. Lithium nitride. So you take the name, you each part of the name, and you figure out what ion it is. Lithium is the first part of the name, so that's going to be your first ion. So you look up lithium. Again, the first part is going to be a metal, right? So it's going to be in this group here. So lithium is right here. It's in group 1, so it's going to have a +1 charge. So we're going to write, oops, let's do it up here. So we're going to have Li plus, right? So we don't usually write the 1, but just to be complete, so you can see what's going on. So we have a 1 plus. And then the next one is nitride. So what's nitride? That's going to be, if you look on your sheet here, you could use your sheet nitride. Nitride is in group 5A. 5 minus 8 is -3, right? If you recognize that ending, nitride, the NITR, that's the beginning of nitrogen. So if you remember that, you can look on your periodic table for nitrogen. So that's going to be this one right here. So nitrogen, it's an N, capital N. So I'm going to write N, it's in group 5, so 5 minus 8 is -3. So it's got a 3 minus charge. And again, to figure out the formula, I take the 3 and I crisscross. So this 3 is going to go down as a subscript for lithium, and this 1 is going to go down as a subscript for nitrogen. Now, 1s we don't write. So we're just going to write it Li 3N. Okay? And last one, again, we're going to divide this up. So first part is your metal, barium. So we're going to look for barium. Again, we're going to look here. Barium is right there. It's in group 2, so it's got a 2+ charge. And we've got, so we're gonna, let's go right up here first. So we got Ba 2+, and then selenide. So selenide, we can try to find selenide on our sheet here. There's selenide, it's in group 6. So it's gonna, 6 minus 8 is -2, so it's a -2 charge. You can also look on your periodic table for selenium, Se. So selenium, selenide. So Se is going to be the symbol, Se, and it's going to have a 2 minus charge. And then you do the crisscross method, right? So if we follow the crisscross method, this is where we need to be careful. So if I follow the crisscross method, I'm going to take this 2, put it down here as a subscript, put this 2 down here as a subscript, and so then we end up getting Ba2 Se2. Now, that is in a way correct, but we normally do not write ionic compounds in this way. We write the ionic compound in the lowest whole number ratio, the simplest whole number ratio. So 2 to 2 is not the simplest whole number ratio, so we're going to have to simplify that to 1 to 1. So again, remember, we don't write the 1s down, so we're just going to write BaSe. So that would be the formula for barium selenide. And so that's how you go from the formula to the name and the name to the formula. Okay, so what I want you to do is go ahead, pause the video, and practice doing these. So follow what we did up here and apply it to these new problems here. So go ahead and pause the video and come back when you are finished and see how well you did. Okay, so you should be done. If you're back, you are done and you want to see what your answers are. So let's follow what we're doing. So K is potassium. So potassium is there, and that's going to be in group 1, so that's going to be a +1. So that's going to be the first name, potassium. And then O is oxygen on your periodic table. So it's a non-metal, so it's right there. It's in group 6. So we're going to drop the ending and add IDE. So if you look here, you can see, that oxide, oxygen becomes oxide. So you drop the ending and add IDE. So oxide. So that's going to be potassium oxide. Okay. What about CaF2? Same thing. The first one is Ca, so you look up Ca and you find Ca and it's calcium. So that's going to be the first part. So calcium. And then F. So F is going to be a non-metal. So here's your F here. And it should say fluorine. But if you drop the ending, you'll see that that should be fluoride. Okay, be careful of the spelling. It's UO, FLUORIDE. So then you write FLUORIDE. So calcium fluoride is the name of that substance. And let's keep going. Zn. Now Zn is one of those special ones. It's not in the S block in the first two groups. It is right, where is that? Zinc is right there. It's a transition metal, but it only has one charge, so it applies. So it's a type 1 ionic compound. So since Zn is zinc, we're going to write zinc for the first part of the name. And then Br is the second ion. So Br is here. Bromine, it's in group 7, so it has a -1 charge. Not that we need to use that, but we're going to drop them in. Bromine becomes bromide. So here's bromide. Bromine, INE, drop the ending, add IDE. Okay. So that would be zinc, bromide. And then here again, silver. Silver is again a transition element, but it is one of those special ones that only has one charge. So we can name this just silver for the first part. And then S is the same as before. So S is sulfur. And so if we look here, again, we'll find sulfur becomes sulfide. So the second part of the name is sulfide. So if you got those right, great. If you didn't, hopefully you realize what your mistake is now. All right, so what about aluminum chloride? So again, we're going to look up in our periodic table, aluminum. You look up aluminum, you'll find that that's Al. And Al is in the third group, so that's going to have a +3 charge on it. So we're going to write down 3+. And chloride is chlorine. So that's in your group 7A. 7A minus 8 is -1. So we're going to have a Cl minus. Okay, again, there's a 1 here. We don't write it, but it's there. And now we crisscross the numbers. So this 1 goes down here as a subscript. This 3 goes down here as a subscript. And it becomes AlCl3. And notice I'm not writing the 1. We don't write 1s. All right, same thing for cesium phosphide. We look up cesium, right? So cesium is right here. It's a group 1, so it's a +1 ion. So cesium plus, oops, I should write it up here. Cesium plus, and then phosphide. Phosphide, if we look on our sheet here, phosphide right there. So it comes from phosphorus. So that's a P, and it's in group 5. So 5 minus 8 is -3. So there it is right here, P. So we're going to use a P. So P, and it's got a 3 minus because it's in group 5. And again, we're going to crisscross the charges. So there's a 1 here that's going to go down there. And so we get, so our final formula is going to be CS3P. Strontium, again, strontium, it's going to be SR, and that's in group 2, so it's got a +2 charge. So SR2 plus. And then oxide again. So again, just like oxide here, it's going to be O. So oxygen, so that's going to be O2 minus. We do our crisscross 2, 2. So we should have SR2O2, but again, we need to simplify that. So 2 to 2 becomes 1 to 1. So SRO. And then finally, cadmium nitride. So cadmium is not in the S block. It's not here. It's in the transition metals right here. So again, it's one of those special ones that has no variable charge. It only has 1 charge. So we can use it in this case. So it's in this category of ionic compounds, type 1. So cadmium, Cd, that's going to be what charge? Well, we can come here and we can use our cheat sheet. So cadmium has a 2 plus. So you can remember that using your sheet. So Cd is going to have a 2 plus charge. Okay, I don't trust cadmium, it's kind of seedy. So, a little humor there. So, then next is nitride. So, that's going to be nitrogen. That's in group 5A. Also, you can use your sheet here. Nitride, where's nitride right there? So, 5A. So, 5 minus 8 is -3 again. So, we're going to do N3 minus, and then you, again, crisscross the numbers of the charges. So this is going to go down as a 2 for the subscript for N, and then 3 is going to go down as a subscript for the D, or for CD, and then you have cadmium, and then so CD3N2. Okay, so hopefully you got those correct, and if not, hopefully you see where you made your mistake and you won't make those mistakes again. All right, well, what about the next one? So the next group, type 2 ionic compounds, this is where you're going to have a metal that has variable charges. So the variable charges need to be specified. You need to clarify what the element is. So for example, if let's say, for example, up here, if I have copper, if I have CuO and Cu2O, right? Based on what we just learned, I would call this copper oxide, right? And also, based on what we just learned, I would call this copper oxide. Well, that's a little strange because, as you can see, both of these formulas are different. If the formula is different, then we have a different substance. You can't name different substances with the exact same name. We have to differentiate between the two substances. So it turns out that copper is one of those elements that can have a multiple of charges. It could have different charges. So in this case, you have a 2 plus charge, and in this case, you have a 1 plus charge. So the way you are going to identify these ions is by using a Roman numeral in parentheses. So the Roman numeral identifies the charge. It does not identify the number of ions of that element. It's just the charge. So this gets back to what I said before. If you know the name of the ions, you just put the names together. Well, in this case, you're going to name the ion by its charge. So that's how we're going to differentiate between this copper ion and this copper ion. So this copper ion is going to be called copper 2 with the Roman numeral. This copper ion is going to be called copper 1. So if I write this down, it's going to be, so if this one's called copper 2. And this one is called copper 1. Okay? So now these are the names of these ions. So copper 2 is the name of this ion. Copper 1 is the name of this ion. So now that we know the names, if we remember the names, we can just put the names together like we did before and name the substance. So it's just that now we're going to have Roman numerals that are going to be part of the name of the ion. And again, the Roman numeral identifies the charge. It represents the charge on the ion. So, for example, iron can be either F2 plus or F3 minus. So if we have F2 plus, then that's going to be called iron 2 because of the charge, iron 2, right? So you just write down iron 2. And you'll notice I'm not leaving a space there. There's no space between there. So it's iron 2 parentheses. There's no space between iron and the parentheses. So this is the name of the first ion. And then we just name this ion the way we did before. That hasn't changed. So what we learned in the first section, in the first part, with the type 1 ionic compounds is exactly the same. That's no different here. So we're going to drop the ending, and then this is going to be chloride. So iron 2 chloride is the name of this compound here, right? If I have iron 3 plus Cl minus, then that's going to be iron 3 chloride. Okay, so that's the name. What's the formula? The formula, you do the same thing. You crisscross the numbers on the chart. So here I have a 2, and I'm going to put that as a subscript for the chlorine. This one has a 1 here, so I'm going to take that and put that there as a subscript. And so the formula would then be Fe, we don't write the 1, Cl2. Same thing here. So if I have the 3 here, the 3 goes down here as a subscript for the chlorine or chloride ion. And then we have a 1. The 1 goes down here as a subscript for the iron. We don't write the subscript, we don't write 1s. So again, it's going to be Fe and then Cl3. So that's the formula for these two compounds. Okay, so when you're going from the formula to the name, we're going to use the subscripts and the known charge on the ion to figure out what the charge is on the metal. So since the charge on your anion is not going to be variable, right? So you got to know the charge on the anion. If you don't know the charge on the anion, then you're not going to be able to figure out the charge on your metal. Okay, so again, you can use your chart here, right? You can use your periodic table, right? You should know the pattern of the charges here. So, for example, bromine, you look up Br, it's the second, this is the second element, so that's going to be a non-metal, so it's going to be on this side. So bromine, Br right here. So Br is in group 7. 7 minus 8 gives you -1. So that's going to be a -1 charge. Br is a -1. You have 2 of them. So if you have a -1 and you have 2 bromines, that means if you multiply that by 2, you get a -2. So your total negative charge is -2. Okay, so that means that, remember, the rule is all ionic compounds are neutral, 0 charge. So if you have a total of a -2 charge, then that means you have to have a total of a +2 charge. And that +2 charge is going to be divided among the number of positive ions you have, the metal ions. So in this case, we only have one metal ion, one Pb. So therefore, the total +2 charge has to fall on there. So that is going to be a +2 charge. So that means your bromine has, or I'm sorry, your lead has a 2+ charge. So that means that lead, Pb, is going to have a 2+ charge. So now that you know the charges, lead is one of those variable charge elements, so you're going to use the Roman numeral to identify the charge. So then the name of this ion is lead 2. And again, the name of this ion it's bromine, drop the INE, add IDE, and you get bromide. So this is lead 2 bromide. Okay, so what about this one? Same thing. We need to start with the anion. What is the charge on oxygen? You have to go either your periodic table, find O, oxygen, and it's in group 6. 6 minus 8 is -2. You could also look on here for oxide. So you got 6 minus 8 is 2. So on your oxygen, you know you have a 2 minus charge on the oxygen. How many oxygens do we have? We have 2 oxygens. So that means that you're going to have, if you have a -2 charge already, you're going to multiply that by 2 because you have 2 oxygens, and that's going to give you a -4. So you have a total of a -4. If you have a total of a -4, that means you need a total of a +4 to cancel it out, to balance the charge. So you need a positive 4 to balance. So now this positive 4 charge is going to be divided among the positive metal ions, the cations. We only have one SN. SN is tin. We only have one tin, so it's got a positive 4. So we're going to have SN 4 plus. So tin is one of those elements that can have multiple charges, so we need to identify the charge with a Roman numeral. So this is going to be tin 4. So that's the name of that ion, tin 4. The name of this ion is the same as before. So it's oxygen, drop the ending, add IDE, it becomes oxide. Okay, so that's again how you figure out the formulas and the names of the type 2 ionic compounds. Go ahead and stop the video and go ahead and do these practice problems here. When you are done, restart the video and see how well you did. Okay, welcome back. So let's see how well you did. So you're going to convert this into the formula. They give you the name, they want the formula. So gold is going to be AU. It's got a 3, that's going to be a 3 plus. Bromide, that comes from bromine. Look on your periodic table. You're going to find that that's a Br minus. So you crisscross these and you get AU, we don't write the 1, Br3. Okay. Nickel 2 nitride. Again, nickel 2, that's going to be Ni. The 2 is the charge, so it's a 2 plus. Nitride, that's nitrogen. Look on your periodic table, that's going to be in group 5. And you'll find 5 minus 8 is negative 3. So N3 minus, you crisscross those, and you get Ni3, N2. So that would be the formula for nickel 2 nitride. What about platinum oxide, platinum 4 oxide? So again, platinum, that's going to be PT on your periodic table. So it's a 4. 4 is the charge, so you're going to have PT 4 plus. And then you have oxide, oxygen, that's in group 6. So again, that's going to be a 2 minus charge. So again, you crisscross the charges and you get PT2O4. But notice here, 2 to 4, is that the simplest? No. So if you left it here, you were wrong. You're almost there. You need to simplify this. So it's not 2 to 4, but 1 to 2. So the formula is going to be PT1, we don't write the 1, O2. So that would be the correct formula. And then titanium. So titanium is going to have a 1 charge. So titanium 1 is Ti, and that's going to be a plus. And then sulfur, sulfide is sulfur, that's in group 6. That's going to have a negative 2 charge. So you're going to have S2 minus. Again, you crisscross charges, and then that's going to be Ti2S for the formula. Okay, so what about these? Now here we need to go from the formula to the name. So for the name, you got to figure out the charge on the metal ion. So you need to know the charge on the fluorine. The fluorine is going to have, it's in group 7. 7 minus 8 is negative 1. And you have 4 of them, so that's going to be an overall charge of negative 4. So you need a positive 4 to cancel it out. You only have one lead, so that's going to be a plus 4 charge. So this is going to be lead 4, and then fluorine goes to fluoride, Fluoride. So lead 4, fluoride. Cr2O3. Again, got to figure out the overall charges. Oxygen is in group 6, so that's going to be a negative 2. 6 minus 8 is negative 2. 2 minus. You got 3 of them, so that's going to be an overall of a negative 6. 2 times 3 is negative 2 times 3 is 6, negative 6. And then, so we need a positive 6 to balance out. So we need a positive 6. This positive 6 is going to be balanced or divided between all of the atoms. So Cr2, we have 2 chromium atoms. So that means that each atom or each ion of chromium is going to be a plus 3. So that means that this is going to be chromium 3 for the first ion, and then oxide for the second part of that ion. So the name is chromium 3 oxide. All right, same thing here. We need to figure out the chloride ion. That's in group 7, so Cl minus. You have 2 of them, so you get a 2 minus charge overall. So you need a plus 2 charge to cancel that out. And so since we only have one copper, that's going to be all on that copper. So the name of that ion is copper 2. And then you bring in the chlorine. So you drop the anion and it's chloride. So copper 2 chloride. Here we have manganese and sulfur. So again, you need to figure out the charge. You need to figure out the charge on the metal. Sulfur is in group 6. 6 minus 8 is negative 2, so that has a negative 2 charge. You have 2 sulfurs, so 2 minus negative 2 is negative 4. So you need a positive 4 to cancel that out. You'll only have one manganese, so that's going to be manganese 4. So the 4 charge is on that one manganese. So it's going to be manganese 4. And then sulfur goes to sulfide. Like that. Okay. Here we have mercury and iodine. So we look up iodine on our periodic table. It's in group 7. So 7 minus 8 is negative 1. So we have 2 of those. So negative 1 times 2 is negative 2. So we have a total negative charge of negative 2. We need a total positive 2 to balance it out. That means the one mercury ion is a positive 2. So this would be mercury 2 iodide. Iodine becomes iodide. Okay. COP, one of my personal favorites. CO for cobalt and P for phosphorus. So phosphorus, start with phosphorus because that's going to be a charge that we know. Phosphorus is in group 5, so that's going to be 5 minus 8 is negative 3, so it's a 3 minus charge on the phosphorus. We only have one, so that means we need a plus 3 to balance it out. So we only have one cobalt, so the positive 3 is on the cobalt. So this is going to be called cobalt 3. Cobalt 3. And then you just add the phosphorus to it, but you drop the ending, so it's going to be phosphide. So cobalt 3 phosphide. Now here we have uranium and bromine. So we start with the anion. Look up bromine. It's in group 7. 7 minus 8 is -1. Uranium. So how many do we have of the bromine? You're going to multiply that by 6, and it gives you -6. We have a total of -6. We need a +6 total to balance out the charge. We have only one uranium, so it's all on that uranium. So this is uranium 6. And then bromine becomes bromide. Drop the ending. Okay, last but not least, we have V and O. Okay, so vanadium and oxygen. So again, we start with the anion, oxide. So oxygen is group 6. 6 minus 8 is -2, so that has a 2 minus charge. Notice we have a 5 there. So that's going to be a 5 times -2. So 5 times -2 is -10. So we need a +10 to balance this out. So +10, we have 2 vanadium ions. So that +10 has to be divided between the 2. So that's going to give you a +5 on each vanadium. So this is going to be vanadium 5. And then oxygen becomes oxide. Okay. So you'll notice that I spent time multiplying by the number of the subscript here to get the total charges to balance out. Now, you don't need to do that. You can work backwards. Remember the crisscross method. If you're going from the formula, if you're going from the name to the formula, then you could use the crisscross method. But if you're going from the formula to the name, you could do the opposite, reverse the crisscross method. So then take the, you'll notice that you can take the subscripts and crisscross them the opposite way toward the top, and you'll get the charges on the ions. Now, the thing you want to be careful of is that's not always the case, because these could be simplified numbers, right? So if you simplify these, then it may not, the crisscross, the reverse crisscross method will get you to the wrong answer. So if you figure out the total charges you need on the negative and the positive, then you can't go wrong with that. So this is a surefire procedure. Okay, so hopefully you did well on that. If not, or if you made some mistakes, hopefully you found what they were and you won't make them again. Okay, so here, what I want you to do now is pause the video, okay, and then see if you can figure out which type is which, and then name them accordingly. So either go from the formula to the name, or from the name to the formula. So why don't you go ahead and pause the video, take as much time as you need, practice writing out the answers, and then come back and see what the answers are. Okay, so you're back. I'm just going to write out the answers for the sake of time. So I'll do a little bit of narration while I'm doing this, but I'm not going to spend a whole lot of time explaining. So this one is going to be potassium sulfide, because potassium is in a main group metal, no variable charge. Copper is a variable charge, so S is going to be -2. So that's going to be divided between the +2. So that's going to be, this is going to be copper 1 sulfide. This is going to be strontium. Strontium is a main group metal, so it's going to have one charge. So this is going to be strontium, fluoride. Chromium is a transition metal, so it's going to have variable charges. Phosphorus has a -3, that's -6, so I need a +6 divided into 3, or divided by 3 is +2. So this is going to be chromium 2 phosphide. Rubidium Rb is in the first group, so that's not going to have a variable. It's not going to have a Roman number because it's not a variable charge. So this is going to be rubidium fluoride. This is going to be barium chloride. This one's going to be magnesium nitride. This one's going to be aluminum oxide. Some people want to say this is aluminium. They want to put an extra I in there. Don't put an extra I in there. Aluminum oxide. Gold. Gold is a transition element. It's not one of those ones that are going to be just one charge. It's going to have multiple charges, so you got to figure out the charge. And you're going to have a Roman numeral. So this is going to be gold 3 chloride. Manganese. Manganese is also going to have variable charge. So this is going to be manganese 3 oxide. This is going to be cobalt 2 chloride. This one is going to be iron 3 iodide. This is going to be now silver. Silver is one of those special ones. It's only going to have one charge, so you do not need a Roman numeral. So this is going to be silver chloride. Cadmium is also one of those special ones. Cadmium is only ever going to have a +2. So this is going to not have a Roman numeral. So just cadmium bromide. Calcium, this is going to be calcium oxide. This can have a variable charge. So titanium is going to be, this is going to have a Roman numeral. So titanium, oops, hold on. That's going to be titanium 4. I should write in a Roman numeral, shouldn't I? Titanium 4 oxide. Now, this is one of those examples where you can't do the reverse way, because if you do the reverse way, take the 2, put it up here on top by the titanium, you would think that the titanium has a 2+ charge. But in this case, when you're doing the crisscross method to get the formula, you had to simplify to get 1 to 2. But in reality, the charges are 4 to 2. Okay, so you got 4. That's why it's a titanium 4 oxide. This is potassium sulfide. This is sodium nitride. This is going to be lead 2 oxide. and this is going to be, excuse me, this is going to be, where's selenium? There you are. So selenium is in group 6, so that's going to have a -2 charge, so that copper is going to be copper 2 selenide. Okay, so those are the names of those formulas. Well, what about these down here? So zinc iodide, what's the formula? So you'll notice that there's no Roman numeral here. Zinc is one of those special ones. So if you don't remember, again, you can always go to here, on your cheat sheet here, to find zinc, which has a 2+ charge. So if zinc has a 2+, iodine has a -1, so that's going to be ZNI2. Okay, mercury has a 2+ charge, sulfide has a -2 charge, so that's going to be HGS. Barium has a +2, chloride has a -1, so that's going to be BaCl2. Vanadium has a 5+ charge, and selenide has a -2 charge, so that's going to be Se2. Oops, wrote it backwards. That's going to be V2 Se5. Gold has a +1, nitrogen or nitride has a -3, so that's going to be Au3N. Iron 3 fluoride, iron is going to have a 3+, fluoride is going to have a -1, so that's going to be FeF3. Tin has a -4, sulfide has a -1, so that's going to, or -2, so that's going to be TiS2. Sodium is going to be phosphide, and I had to simplify this in case you're wondering. So if you do the crisscross method, you're going to have 2 to 4, but then you simplify 1 to 2. Sodium phosphide, so that's going to be sodium phosphide has a -3, sodium has a +1, so it's going to be Na3P. Cadmium, okay, cadmium again is not a variable charge, so it's not going to have a Roman numeral, so that's why there's no Roman numeral here. So the charge again is going to be +2. Oxygen or oxide ion has a -2, so it's 1 each, so they're going to see CdO. Magnesium, that's going to be a +2. Bromide is a -1, so it's going to be MgBr2. Okay, so those are the answers. Oops, sorry. So those are the answers to all of these. So hopefully you got them all correct, and if you didn't get some of them right, hopefully you figured out what your mistake is. Okay, so those are the first 2 types of ionic compounds. The next type is with the polyatomic ions. And again, the rule of thumb, the rule is, if you know the names of the ions, then you just put the names of the 2 ions together, and that becomes the name of the compound. And it's even easier with the polyatomic ions, because the polyatomic ions have their own name that you don't need to change. You don't need to worry about dropping the ending and adding IDE. It's just the name. The hard part, though, is you need to memorize the names. So again, on your little cheat sheet here, you have a table of some of the common polyatomic ions, and each ion has a formula and a particular name that goes with it. So HCO3 minus, is called bicarbonate, or it's called hydrogen carbonate. Okay, you can remember hydrogen carbonate because it looks like carbonate ion, which is right here, but with a hydrogen. So it's hydrogen carbonate or bicarbonate. Okay, permanganate is MnO4 minus, acetate C2H2O2 minus, cyanide Cn minus. So all you need to know these names, and if your formula has this ion, then that's the name of the ion that's going to be in the name, right? So if you know the names of the ions, of the polyatomic ions, you stick them together. So here is the example. You have the ammonium ion. So NH4 plus is the ammonium ion. So ammonium is going to be the name of the first part of the name. It's plus. So this is the only time I think that you have a non-metal positive ion, cation. Okay, but it's a polyatomic ion. So here you need to recognize when you have a polyatomic ion. So here NH4, you should recognize that. So this ion is going to be the first part of the name. This Br is going to have the second part of the name. So NH4 is ammonium. So you write ammonium. And then Br, bromine, drop the ending, you add IDE, so bromide, same as before, nothing new. So again, if you know the names of the ions, you stick them together, and that's the name of the compound. So here, permanganate ion. So if you notice, you have a permanganate ion here, so you divide, here's your metal ion, here's your polyatomic ion. Most of the polyatomic ions are going to be negative. So they're going to come this in second. So first is your metal, and then second is your negative ion. So here again, you just know the names of the ions. Potassium permanganate. So that's the name of this compound. Potassium permanganate. And that's it. That's all you do. But you need to know the names of the polyatomic ions. If you don't know the names of polyatomic ions, it's going to be really difficult. If you know the names of polyatomic ions, it's going to be really simple. Okay. When we're going from the formula, the name to the formula, everything is the same as before. You have to know the charges on the ions. And so same goes for polyatomic ions. You need to know the charges on the polyatomic ions. If you don't know the charges, you're not going to figure out the formula. So you got to use your cheat sheet or memorize, right? So eventually, if you're going on in chemistry, you're going to have to memorize these, okay? So this is your cheat sheet for the homework, but I want you to memorize them. You have to memorize them for the test. So magnesium, that's going to be Mg. Sulfate, you have to look up sulfate if you don't know. So sulfate is SO4, and it's got a 2- charge. A cool way to remember that the sulfate or the sulfite, since they're very similar, you'll notice the sulfate has one more oxygen than sulfite, so you could remember sulfate versus sulfite by the number of oxygens. The one that has more oxygens is the one that has ATE. The one that has less oxygens has ITE. Okay, so that's one thing you can remember. The other thing you can remember is, well, if you know the charge on sulfur, right? Sulfur is in group 6. 6 minus 8 is -2. Notice that these have -2s. Look at the sulfur. So if you remember that sulfur has a -2, then you can remember that sulfate and sulfite have -2 charges. Now this doesn't work all the time, but it works fairly commonly, right? So notice here we have phosphate It looks very similar to sulfate, right? Has the same ending, but it's now phosphorus instead of sulfur. Well, what's the charge on phosphorus? Phosphorus is in group 5. 5 minus 8 is -3. Look at the charge on the phosphate. It is also a -3. So there are patterns that you can look out for to remember charges. Now, this won't work for nitrate and nitride. You'll notice that they have a -1 charge. If you were to look at nitrogen, nitrogen is also in group 5. Nitrogen has a -3 charge. So that wouldn't work for these. Obviously, they have -1s. So the rule that I'm giving you is a rule of thumb. It's going to have exceptions, but it is helpful. Okay, so I have to know what sulfate is, and I have to know the charge. So again, you write down sulfate SO4, and it's got a 2- charge. And magnesium is in group 2, so it's going to have a 2+ charge. And again, the charges are equal and they cancel out, so you'll only need one each. So it's going to be MgSO4 is the formula. Okay, what about barium hydroxide? You look up hydroxide if you don't remember. Hydroxide is there, it's OH minus. So you got OH minus, and then barium is in group 2, so that's going to have a 2+ charge. If you crisscross, then the formula is going to be that should be a Ba. So that's going to be BaOH2. Now, notice what I did here. I put the OH in parentheses because I need 2 OHs to balance out the Ba. So the parentheses are there to help clarify what I have 2 of. If I don't have the parentheses, if I wrote it like this, BaOH2, this would look like I have 1 barium, 1 oxygen, and 2 hydrogens. That is not the same molecule as this. This is, I don't even know what this is, right? So if you have more than one polyatomic ion, you need to have parentheses surrounding the polyatomic ion, and then the subscript tells you how many of that polyatomic ion you have. Okay? So that would be the formula for barium hydroxide. And then iron 3 acetate. So iron 3, we know from the Roman numeral, it's got a 3+ charge. Acetate, if you don't remember, acetate is right here. So it's C2H3O2 with a minus. So C2H3O2. So C2H3O2, and it has a minus. So in order to balance out the positive 3 charge, I need 3 of these. So I'm going to need parentheses. So this is going to be Fe parentheses C2H3O2 close parentheses, and I need 3 of them. So there's going to be a 3. So that would be the formula for iron 3 acetate. All right, so go ahead and pause the video and work on these examples. Also, don't forget that they continue here. So here they want you to go from the name to the formula. Here they want you to go from the formula to the name. So go ahead and pause the video, write out your answers, and come back and check your work. Okay. Welcome back. So let's see how you did. So again, I'm just going to run through these and give you the answers. So this is going to be Li2CO3. So carbonate is a -2. So this is going to be AlCN3. This one is going to be K2SO4. Ammonium carbonate, that's going to be NH4 with parentheses, and that's going to be a 2 because my carbonate has a -2 charge, so carbonate is CO3. Iron 3 sulfate, that's going to be Fe2 SO, excuse me, SO4 with parentheses, and that's going to be a 3. Okay. Zinc sulfite. Zinc is going to have a positive, excuse me, it's going to have a positive charge on there. So it's going to be a +2. It's no Roman numeral. Notice that. So it's +2. Sulfite is SO3, 2. So this is going to be zinc SO3. Copper 2 nitrate. Nitrate has a -1. Copper has a +2. So this is going to be CuNO3, 2. Nitrite, calcium nitrate, calcium is 2, so it's going to be calcium, and then here nitrite is NO2, and you're going to have 2 there. Copper 1 bicarbonate, again, bicarbonate is going to have a -1 charge. Another way you can remember that from the pattern here. So you'll notice here that carbonate has a -2 charge on there, CO3. Now here you'll notice that hydrogen HCO3 has a 1- charge. You can remember that if you remember the charge on carbonate, you can remember the charge on the bicarbonate being 1 less, because normally hydrogen normally exists as H+. So imagine putting an H+ with a CO3 2-. So the plus is going to cancel out one of the minus charges, and you get a -1. So that's a good way to remember how to do that. Okay, so bicarbonate is going to be HCO3-. And so copper, that's going to be a +1, so it's CuHCO3. Mercury is going to have a 2 charge, mercury 2, and phosphate is going to have a -3. So that's going to be Hg3P2. Here, this one is going to be lithium hydroxide, so LiOH. This one's going to be, oops, what am I doing? It's too late. All right, so lithium hydroxide, we're going from the formula to the name. So this is going to be, as I said, lithium hydroxide. This one is going to be iron 2 permanganate. This one's going to be barium phosphate. This one's going to be So this is CrO4. So CrO4 is going to be chromate that has a -2 charge. So that's going to be, that means I have a +2 charge on my iron. So that's going to be iron 2 chromate. This is dichromate. So dichromate is also going to have a -2 charge. So that means zinc has a +2. So zinc is one of those special ones that doesn't have a Roman numeral, so it's just going to be zinc, and then dichromate. Okay, so here we have cyanide. So we have 3. So this is going to be cobalt 3 cyanide. This is going to be sodium bicarbonate. Sodium bicarbonate. SN is tin. So tin can have variable charges, so that's going to have a Roman numeral. Sulfate has a -2, so that means I have tin 2 because there's a +2 on tin to balance the -2 charge on sulfate. And then lead, sulfate has a -2 charge. Oh, sorry, that's sulfite because it has 3 instead of 4. Notice 4 you have more, so it's 8. You have 1 less, so that's 8. So sulfite, I have 2 of them, -2. So that's a -4, so that's a positive 4 on the lead. So this is lead 4 sulfate. And this is going to be manganese acetate. So it's manganese 2 acetate. Okay, so those are the names. Now, be careful that you're not mixing up the names here. Nitride, nitrite, nitrate. So IDE, that's going to be your monatomic ions, not polyatomic. So that's going to be just your single element, right? So that's going to be, nitride is going to be N3 minus. Nitrite is going to be NO2 minus. Nitrate is going to be NO3 minus. Notice the one that has more oxygens is the ATE. The one that has less is ITE. Phosphide is the 1, IDE. So it's a 3 minus. So 1 element. Phosphate is your polyatomic ions. PO4, 3 minus. And you can remember again that this has a 3 minus because it has phosphorus in there, and phosphorus has a 3 minus. Phosphide ion has a 3 minus. Sulfide is an S2 minus. So IDE, single atom, monatomic. And then sulfide is SO3, 2 minus, and sulfate is SO4, 2 minus. Notice again that they all have 2 minuses. Okay. Alright, so go ahead and keep practicing. So go ahead and pause the video and work on these and see if you get them right. When you're done, go ahead and restart the video. Okay, you're back. Hopefully you got them right. So let me write these out really quickly. So you have ammonium sulfite. So ammonium is NH4. You have a +1 charge. Sulfite is that one that has a -2. So I need 2 of these to balance out. And then I put SO3 there. Lead 2 phosphate. That's going to be, let's see, lead PB3, PO4, and then I put parentheses because I need two of those. Okay, barium sulfide. So sulfide is IDE, so that's going to be this one there. So they both have a 2 charge, +2, -2, so it's BAS. Magnesium, +2 charge. Nitrate. Nitrate is this one here, has a -1 charge, so I'm going to need 2 of those. So magnesium, NO3, 2. So I need 2 nitrates to balance the +2 charge on the magnesium. Titanium has a +1 charge. Nitride. Nitride is a single atom ion. It's not a polyatomic ion. So nitride is a 3-. So that means I have Ti3N. Okay. So copper 2 phosphide, again phosphide, IDE, that's going to be a single atom, that's that one there. So P3-, so that's going to be Cu3, P2. Cobalt 3 sulfate, sulfate is this one here, has a 2-, so that's going to be CO2, and then sulfate, and that's going to be a 3 there. And then zinc has a +2 charge. Nitrite is this one here, has a -1. So zinc, I'm going to need parentheses NO2, 2. So there is the formulas for those substances. Okay, hopefully you did well on that. And again, if you made mistakes, hopefully you see what they are and you won't make them again. Okay, so we're at the penultimate page, the second to last page. So in this one, we're going to be talking about binary covalent compounds. So we're not talking about ionic compounds anymore. So now we're going to talk about covalent compounds. In a way, covalent compounds are easier, but you need to remember prefixes. You have to put prefixes. So you have these Greek prefixes that you need to put at the beginning of the name of the element. So here we're not talking about ions anymore because you have a metal, or I'm sorry, you got a nonmetal or metalloid with a nonmetal or metalloid. So in these cases, you're going to need to add a Greek prefix in order to identify how many of that atom you have in your compound. So remember, the Roman numerals we used for the ionic compounds did not tell you how many of each ion you had in the formula. The Roman numerals only told you the charge on the metal ion if it was a variable charge. Greek prefixes are not, I repeat, not used in naming ionic compounds. They are only used in naming the binary covalent compounds. Okay? So, the way you're going to do this is you have the name of your nonmetal, the first nonmetal in your formula or metalloid. If you have a certain number of those, then you're going to have to identify that with your Greek prefix. If you only have one, then you're not going to use a Greek prefix to identify it. We usually don't use the Greek prefix, which is mono. So mono would be the Greek prefix for 1. If it's your first element in the formula, in your binary formula, then we don't use mono. We just use the name of the element. Whatever that element is, we just write the name down without the prefix. The second one will always have a Greek prefix to identify how many of that you have. And again, just like in the ionic compounds, you have to drop the ending and add ID. So remember that. Okay. So for example, here we have P for phosphorus. So there's only one of them, so you don't need a Greek prefix. We're not going to write a Greek prefix. So it's just going to be the name of the element, phosphorus. And then Cl is chlorine. We have to drop the ending, so that's going to be chloride. But we have a 5 there. So we're going to have to use the Greek prefix for 5. So again, you go to your little cheat sheet here and you find the Greek prefix for 5. So here's our Greek prefixes: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. Okay, a lot of these you're probably already familiar with. Mono, mono, di, tri, tetra, you probably, tetris. Tetris means 4. You only got those 4 shapes to work with in the Tetris game. If you remember tetrahedral, if you've gotten there yet, you will. So tetra is 4, penta is 5, pentagon. If you notice the Pentagon building has 5 sides. 5-side shape is pentagon. Pentagram is a 5 pointed star. Hexa is 6. Hepta is 7. Octa, you can remember that with octopus. And then, of course, nona and deca, those are probably going to be new. Okay, so we had 5 chlorine, so that's going to be penta. So we're going to write pentachloride. That's it. That's the name of this covalent compound. So we do the same thing for SO4. Again, we only have 1 sulfur, so we're just going to write sulfur. No prefix. We have 4 oxygens, so look for our Greek prefix. 1, 2, 3, 4. So it's tetra. So we are going to write, tetroxide. Tetroxide. N2O. Now here we have 2 nitrogens. So now we do need to use a Greek prefix. The Greek prefix is di. So it's going to be dinitrogen. So 2 nitrogens. And here we have 1 oxygen. So it's going to be monoxide. Notice that we dropped one of the O's, right? It would sound kind of strange if it was monoxide or monoxide. That's probably... So you don't want to say it like that. Monoxide. So they drop the O, and it flows off the tongue more easily. Okay, so here they gave us the name. So going from the name to the formula is actually really easy if you know the Greek prefixes. It literally tells you how many of each one you have. So dinitrogen means you have 2 nitrogens. So I'm going to have N2. Tetroxide. Notice I spelled it wrong here, so you drop that tetroxide. So tetra means 4, so that means you have 4 oxygens. There you go. Now notice that it's not simplified. It's not simplified because it's not an ionic compound. You leave it this way. Okay. So be careful not to mix up covalent compounds with polyatomic ions. Polyatomic ions have a charge. Covalent compounds do not have charge. So be careful of that. So for example, SO3. If you said that was sulfite, you would be wrong. Sulfite would be SO3 2-. So notice there's no charge here. So this is not a polyatomic ion. So you would not write sulfite. So this is a molecular or covalent compound. So you would write it as such. So you only have one sulfur, so it's just sulfur. 3 oxygen, so that's going to be tri for the 3, and oxide. So sulfur trioxide. Again, no charge, so this is not nitrite. It is going to be nitrogen, no prefix because you only have one, nitrogen, and then we have 2 oxygen, so dioxide. Okay, so here, calcium, notice you have a metal and a non-metal. So metal and non-metal indicates ionic, so that's a dead giveaway. So if you have a metal in your formula, it's most likely going to be ionic. Unless you've got nothing but metal, then it's just going to be a metal. But here we have metal and non-metal, so this is ionic. So this is going to be calcium sulfate, or sorry, sulfite. Again, we have a metal and a non-metal. So this is going to be ionic. So this would be sodium, and then that's going to be nitrite. Okay, so at this point, go ahead and pause the video. And for the rest of this, you're going to have to do the more practice. So you're going to practice going from using your covalent compounds. So you're going to go from the formula to the name, and then from the name to the formula. And then for the last page, it's all mixed up. So you've got all of it mixed up, going from the formula to the name, and then from the name to the formula. So go ahead, pause the video, and then write out your answers, and then come back and check your answers. Okay, welcome back. So let's go over this. So what you should have gotten for this part is this should be diboron trioxide. This should be nitrogen trichloride. This is going to be diphosphorus pentoxide. Notice I dropped the A. Dinitrogen tribromide. Dinitrogen dioxide. Now here I have chlorine. I only have one of them, so I'm just going to write chlorine. Chlorine, and then that's going to be pentafluoride. Notice it's UO. Try not to make that mistake. Carbon, so we only have one, so it's just going to be carbon. I'm not going to write monocarbon. It's not monocarbon, it's just carbon. So carbon, and I have 4, so that's going to be tetrachloride. And then for this one, I only have one sulfur, so it's going to be just sulfur. And then I have hexafluoride. For these, I'm going to write the formula. So iodine, so there's no prefix, so it's just one I, and then monobromide, so Br. Disulfur, so that's going to be S2, and then dioxide, that's going to be O2. Phosphorus is just 1P. Trichloride is going to be Cl3. Xenon is Xe. Pentafluoride means I have 5 fluorines, so it's F5. So those are the answers for this part. And again, hopefully you got most of them right, if not all. And if you made any mistakes, hopefully you know what they are and you can avoid those mistakes in the future. All right, for the last page, again, you can either pause it, or if you've already done it, you can just look at your answers now. If you haven't done these yet, then go ahead and just pause the video and then work on these and come back. Okay, so what are the names of these things? Okay, so this one is going to be Cesium Chloride. It's ionic. This one is going to be, this is ionic metal, non-metal. So this is going to be silver nitrate. Barium and that's going to be chromate. KOH, that's going to be potassium oxide. Zinc, okay, so zinc has no Roman numeral, so it's going to be just zinc, and that's carbonate. Manganese bromide. Manganese bromide. This is ammonium, so ammonium iodide. Okay, so no metal, so just non-metal, so this is going to be Greek prefixes. So di, iodine, and then, pent oxide. So I have 5 oxygens. Up here, I have copper, so I'm going to have a Roman numeral. So this is going to be copper 2, and then I have phosphate. This is going to be arsenic, As, arsenic. As is a metalloid, so we got to be careful with this one. So As is a metalloid, right? So that's going to be, we're going to have a metalloid with a non-metal, so that's going to be Greek prefixes. So I have arsenic, trifluoride. Okay, we have dichromate here. So we have nickel, polyatomic ion. So this is going to be nickel. Dichromate has a -2, so this has to have a +2. So it's going to be 2, nickel 2, dichromate. Bismuth. So this is going to be bismuth nitrate. Okay, that's going to have I believe, a variable charge. Where is Bi? Okay, so actually no, it's not going to have a variable charge. So that's going to be a negative. That's going to be a positive 3 charge. So that's going to be, let's see. Bismuth. Nitrate. This is going to be calcium hydride. This is going to be tin 4 sulfide. So no metal, just non-metal. So this is going to be dinitrogen tetroxide. tetroxide. And here we have platinum. So this is going to have a Roman numeral, so it's platinum 2 carbonate. Okay. Okay, so now we want to go from the name to the formula. So this is going to be sulfur dioxide. That's going to be SO2. Ammonium phosphate. That's going to be NH4 3PO4. Strontium hydroxide. That's going to be SrOH2. Sodium sulfate. That's going to be Na2SO4. Cadmium nitrate. That's going to be CD NO32. Silicon dioxide, that's going to be SiO2. Cobalt-2 chloride, that's going to be COCl2. Iron 3 cyanide, that's going to be FeCN3. Osmonium 8 oxide. We need to find osmonium on our periodic table. Okay, so we know that oxygen is -2. So we need 4 oxygen. So this is going to be OSO4. Cobalt-3 sulfide, that's going to be CO2S3. Nitrogen trioxide, NO. So nitrogen, there's no prefix, so that's just 1, and then we have trioxide. Tungsten is a W. So tungsten 5 sulfite. Sulfite is SO3. That's a 2 minus. So we're going to have that 2, tungsten 2, and SO3 5. Mercury 2, so that's Hg, and then F2. Aluminum carbonate, that's Al. Carbonate is a -2, so that's going to be Al2 CO3 3. Barium permanganate, so barium is a 2+ charge and permanganate is a -1, so we're going to have Ba permanganate MnO4. Oops, don't want the minus, but it's there. 2. There you go. Potassium phosphide, that's going to be K3P. Lithium and bicarbonate, that's going to be LiHCO3. And then dichlorine, so that's Cl2. Hexa oxide, that's 6 oxygens, O6. So that's going to be the answers to this page here. So hopefully you've got the hang of answering or naming these compounds, going from the names to the formulas, or from the formulas to the names. Okay, so again, you might want to review this a little bit. There is a homework assignment, so you, after this video and after you've done your practice problems, go ahead and start on the homework. The homework is actually going to be graded, so use your guide here to help you answer the questions on the homework. All right, thank you for joining me, and good luck, everyone.